Alright, so for this one we're going to do number 27 in the homework. We're asked to find this initial value problem where we're given y double prime plus 25y equals g of t, with y at 0 equals 0 and y prime at 0 equals 2. So the first thing we're going to do is just kind of do the Laplace transform of the left side. Nothing new here. S squared y of s minus 0 minus 2 plus 25 y of s is equal to, well, the Laplace transform of this side is going to be g of s. And you'll see why we did that in a moment. But for now, let's group these y of s terms. S squared plus 25 and that leaves us with a negative 2, so I'm going to add that over to this side. So that's where that negative 2 went. It went over to this side. Just basic algebra. Y of s is equal to g of s over s squared plus 25 plus 2 over s squared plus 25. Okay, so we have y of s, so we can use the inverse Laplace transform to find y of t, giving us the initial value problem. So let's do this one first. This one's quite simple. It's just going to be 2/5 sine 5t. And that's because remember, we need a 5 up top, but the whole thing needs to equal 2. So 2/5 times 5 is 2. And now this one, g of s, this isn't bad because it's 2 Laplace transforms multiplied by each other. We have g of s times 1 over s squared plus 25. Well, that's just the same as sine of 5t, or 1/5 sine 5t, because we need a 5 in the top, convoluted with g of t. And then that, of course, is equal to this formula. So we're going to have 0 to t, f of t minus v, so 1/5 sine of, sine 5, and instead of t, we need to do t minus v, g of v dv. Plus, I'm going to run out of room, so I'm going to write it right here, 2/5. Actually, no, you know what I'm going to do? I'm going to write it over on this side. We have 2/5 sine 5t. And we just solved this doing a regular inverse Laplace transform. And this whole thing is equal to y of t. So that's how you solve the initial value problem for this. Again, we just found the Laplace transforms of both sides like we usually do in these problems. The only difference is this is a convolution. So it's a little bit different of an inverse Laplace transform. But all in all, not too bad. This is going to give you the answer. Okay, so in this problem, this is number 28 in the homework. Another convolution. This one's not really an initial value problem because we aren't dealing with any derivatives. But nonetheless, we want to find y of t. So the first thing we're going to do is do the Laplace transforms of both sides. So this will be y of s. This will be plus 20. Well, this is going to be the convolution of f and g, where f is e to the 20t, and g is y of And we're going to need to find the Laplace transform of that. But for now, I'm just going to leave it as that. And sine 5t is just 5 over s squared plus 25. Okay, so now moving on, we're going to find the Laplace transform of that term. So we have 20, and the Laplace transform of a convolution is just the multiplication or the product of both terms in the convolution. So this is just 1 over s minus 20. And this is just y of s. It's equal to 5 over s squared plus 25. Now what we want to do is factor out the y of s's. And we're going to get in the inside 1 plus 20 over s minus 20. Equal to 5s squared plus 25. Okay, so now what do you think we should do? I think the best thing to do would be find a common denominator on this side, because it'll make it easier for simplification later. Where we have s minus 20 over plus 20 over s minus 20. Of course, these would cancel, giving you the 1, and that would give you the 20, s minus 20. Just common denominator. These will cancel. Is equal to 5. That's a 5, not an s. Just remember that. I know they look similar. So we're left with s over s minus 20, which I'll divide over to the other side. So y of s is equal to 5 s squared plus 25 over s minus 20. Now what we're going to do here is we're going to move it over here. 5 times, we're going to use this kind of trick here where you can multiply the bottoms and the tops. We're going to get, that's an s, so s, whoops, nope, it's a 5. 5 s minus 20 over s squared plus 25. All right. So now what we're going to have to do is a partial fraction. So I'm going to erase this work here so we can solve it, giving us a little bit more room. Alrighty. Now what we got to do here is just basically a simple partial fraction over s squared plus 25 is equal to a over s plus b s plus c over s squared plus 25. So now what we're going to do is multiply the denominator, 5s minus 20 is equal to a s squared plus 25 plus b of s plus c times s. So if we say s is equal to 0, we get 25a is equal to 100, or negative 100 rather. So a is equal to 4, or negative 4. And if we collect the s squared terms, a plus b is equal to 0. Nope. Yep, 0. B is going to be 4. And let's just collect the s terms. So we have c That's the only s term on this side. The only s term on the other side is 5. I don't know why I wrote the equal sign there twice. But there's our answers for A, B, and C. So we have negative 4 over s plus, where's our B? 4s plus 5 s squared plus 25. And then the inverse Laplace transform of this, again, nothing too bad, negative 4 plus 4 cosine 5t. And since beta's the top there, we're just going to get plus sine 5t. And remember, this is equal to y of t. And that would be the answer for number 28.